is being recorded, and that change is detected by this fellow called as transducer. This is the most important component. Okay, so this detection will be now delivered, transferred into electrical form of signal, and it will be displayed. Okay, so how does this biosensor came into existence? उसका evaluation कैसे हुआ था? It's because of this gentleman named Leland Clark. So when people were actually looking at the so-called living systems, especially when doctors used to start the so-called surgeries and all, there used to be a lot of difficulty in detection because doctors don't have an idea like what is the state of the solution, मतलब उसका pH क्या है, उसमें electrolyte content कितना है, ऑक्सीजन कंटेंट कितना है बॉडी में, ये सब मतलब ड्यूरिंग दैट पॉइंट ऑफ टाइम people don't know like about all of this. There was no detection system. So this gentleman, when he invented the glass electrode, glass electrode basically uses a platinum and it will be able to record the so-called oxygen liberation. So once he has come up with that invention, several modifications has happened, and the doctors were able to do many successful deliveries. Billions and billions of the lives have been saved because of its invention. Okay, because real-time monitoring of oxygen while operating was possible. Okay, in the same manner, looking at is so-called invention. Many people started to look at the biological matter, and they started to use it for biological purposes at the same time for non-biological purposes also. Okay, and such kind of devices are called as biological sensors. Okay, it can be very big, it can be small, it can be portable, it can be wearable. You have different types of biological sensors available in the market. Okay, so what are the components? As I said earlier, we have 4 important components. This component, you can actually take it out because this is just a display. This is your output. You measure it in the form of electrical signal. So the 3 basic components will be analyte, bioelement, transducer. The bioelement and the transducer together will be always attached to different types of interactions. Usually they go by physical absorption method or by chemical fixing method. Okay, there are different methods of fixing your bioelement onto the transducer. So once these two fit, the properties should not change. That's a criteria. And once they are fit, then we introduce it to an unknown sample. This is your analyte. This is what we want to measure. So once you measure the analyte, based on whatever the reading you got, you can actually do the intervention. Okay. So working principle same hai. As we are looking at biological parameter matlab is simply made up of chemicals. So chemicals interact. So definitely you have an interacting partner for everything. Okay. So your analyte can be anything, and its interacting partner will be your bioelement. For example, let's say you have an enzyme here. Automatically, this will be the substrate. You have a substrate here. Automatically, this will be the enzyme. You have a DNA here. Usko complementary DNA यहाँ पे होगा. Okay, and same way you have so-called antigen here. Antigen matlab something that actually can cause you give you a harmful stimuli from a living creature. That's called antigen. And हमारे body में उसको contraction में हम लोग antibodies prepare करते हैं. So if you have antigen here, you have antibody here. So this way everything has its counterpart which they interact with. So depending upon what you want to actually see, you have different types of analytes. You can have microorganisms, you have DNA, you have sugars, you have proteins, you have peptides, you have simple amino acids, you can have tissues, cells on the whole, you can have bacteria, you can have enzymes or enzyme receptors, antibodies, etc. Okay, and depending upon what you are actually looking at, your biological element vary. क्योंकि ये यहाँ पे जो है उसके हिसाब से यहाँ पे हमारा binding partner बदलता रहेगा, and you call this as biological element. Now this biological element, I said, this is being fixed onto a transducer. Now we have different types of reactions in our living systems, and each and every one of them have their own thermodynamics, right? They have their heat, they have their energy-based dynamics. So in some of the reactions, you can see there is a change in the mass, which is accompanied with the change in the so-called magnetic properties of that particular compound, or the so-called any wave pattern of something. Or you can see that the optical nature of this entire complex is going to get altered. Okay, the spectrophotometric view is going to get altered. So each and every reaction has its own outputs. Okay, energy based outputs. And what we are doing, we are actually trapping that energy based output, and we are going to give it in the form of an electrical signal. So depending upon what we want to sense, we have these different kinds of transducers available in the market. For example, if you want to so-called look at the electrons or conductance properties, then मतलब electroactive properties देखना है. In that case, you use electrodes. If you want to look at the ionic concentrations, pH, then you use semi-conducting pH electrodes. If you want to look at the heat-based activities, then you use thermistors. If you want to look at the optic light-based, you use photodetector systems. If you want to look at the mass changes, then you use piezoelectric media. So depending upon what kind of change you want to see, you have these different varieties of sensors, transducers available in the market. All of these transducers will be giving you a final output, which will be coming out in the form of an electrical signal. Okay, and sometimes in between you may have to use these additional compounds to filter or to get a clear signal. Okay, so you can use an amplifier, you can use a filter, you can use a converter, you can use a linearizer, you can use a compressor, anything. These are all the kind of technical devices that can be used after the transducer to enhance the signal or to avoid any sort of a background noise. Okay, so working principle, as I said earlier, most of the biological phenomenon do require enzyme. So enzyme working principle do apply here also. So now let's look at the types of the biosensors that we have. We have 5 different types of biosensors based on this component, transducer component. Okay, so first one is resonant biosensor, which means that when a so-called when your analyte and when your bioelement, both of them bind to each other, they bring about a change in the surface wave acoustics. Okay, or so that's called as resonance. So initially the so-called the device measurement, the wave frequency with respect to the device frequency is in a match. You call it as resonance. Okay, so when you introduce the analyte, that particular resonance is getting disturbed and you're actually getting a change in the frequency. This frequency can get recorded. That's happening because of the change in the mass. Okay, and this kind of detection is termed as resonant based detection. So what is the transducer that we are using here? You are using an acoustic wave transducer. So this is very, very crucial in recording the waves which can be pertained to sound waves or which can be pertained to the so-called the waves generated because of magnetic induction and all. Okay, so this is one sort of a sensation that we actually come across. So applications, we can use resonant biosensors in hearing aids. People who have aids defects with respect to hearing and all, you can see like up to what extent they can listen, and you can make the devices and use certain amplifiers through which they can be able to listen properly. Okay, so this is the first level of detection, resonant biosensors. Coming to the second type of biosensors, optical biosensors. These are the most common biosensors that we use in day-to-day life. Okay, like in your remote, like your smartwatches, smartphones, the so-called laptops, okay, or biometric devices, lockers, everywhere you tend to see that now we are using the technology. So most of these technologies basically rely on optical systems, optical detection. So how do we do that? We rely on the light properties, the so-called OD, optical density. So each and every particle do have its own optical density when they are given a so-called set of light. Okay, let's say we have so many people here in the class right now, more than 50. So let's say I'm giving my biometric fingerprint. So when I'm giving a fingerprint, so I have a specific region group pattern through which I'm actually going to get a specific OD, optical density. Okay, and next time when somebody comes and puts their finger in this place, that OD will not be a match. Okay, because I have given my reference and that reference only has to be matching, and that's how my biometry gets recorded, and that's how the others biometries also gets recorded. So when you go and give your fingerprint, your recording is being done. Okay, it will be checked onto a reference value, and if there is a reference value being found, that will be considered. Okay, same thing happens with your so-called fingerprint sensors on your phones and laptops also. Okay, so you have a capacitor based optical detection system, So this capacitor-based optical detection system will be able to look at the pattern that is actually coming across the light. If the pattern matches the original reference pattern, then only it will be opening up. So this is we are now using the light-based phenomenon, especially the spectrophotometric phenomenon. Okay, so this is a block diagram of the so-called optical detection system where you're going to have a silicon wafer. Onto the silicon wafer, you can actually load your so-called sample, a protein sample that has to get detected. You can put it in an analyte. When the analyte comes across it, and if you see any change in the diffraction pattern, and this can be recorded, and this is what is going to give you the output. Okay, so this is how your so-called optical based डिटेक्शन सिस्टम्स विल बी वर्किंग. ओके, हमारा मोबाइल फोन्स में ऑप्टिकल आईआर सेंसर्स है, हमारा जो स्मार्ट वॉचेस है उसमें आईआर सेंसर है. वी हैव अदर टाइप्स ऑफ सेंसर्स आल्सो अवेलेबल इन आवर स्मार्ट वॉचेस एंड ऑल. सो व्हेन वी simply walk, this IR sensor get activated. You can see actually when you lift the watch, there's a green light or the red light coming out. Okay, so that's basically coming out because of this activity from IR sensor. So that way motion detection can be recorded. Okay, and same way you have other sensors also available which actually look at the different parameters on your so-called surface, and they will be able to give you a reading of SpO2, because current generation watches are coming with SpO2 detection, and some of them will be equipped with pulse recognition. Okay, so this way we have this optical based biosensors been working. So they are the most commonly used biosensors in household by a common man. Then we have thermal detection biosensors. Usually when we go ahead with so-called exothermic reactions or endothermic reactions, in such cases we can use this. Okay, we have a transducer called a thermistor. Thermistor will be able to see what are the temperature based changes that are happening with the reaction, and based on that we will be able to diagnose. Okay, and not just that, we will be able to identify certain things like किसी का बुखार हो गया है, so we use a regular digital thermometer and then we can get the reading. That's a simple what do you say, thermal detection system that is available in the market. And other than that, we have complex thermal system where we have probes which will be able to identify different types of chemicals like pesticides or different types of pathogenic bacteria and all. Okay, so these are about temperature based sensors. Now coming to the fourth category called as ion sensitive methods sensors. So ion sensitive, we are going to look at the ionic concentration in a specific media. Okay, so depending upon what we want to look, we have two different kinds of sensors being utilized. One are ISFET and the other one is ENFET. EN stands for enzyme, FET stands for field effect transistor. Field effect, what is that field that they are actually talking about? So when you want to measure the ionic concentration, you require a certain area. So your probe do have its area. When the probe is inserted in the surrounding, in the vicinity, we calculate the number of ions available in that vicinity, and we will be coming out with the solutions. We will be coming out with the diagnosis. So this kind of a transition is called as field effective transition. So what are we actually measuring here? We are measuring the ionic concentration. In case if you are just measuring the hydrogen ion concentration in a media, that is basically used for pH detection. So our enzyme linked or enzyme based field effect transistors are usually used for pH detection. Other than pH detection, we have also many other ions being available in the living systems, and we can use ISFET, ion selective field effective. Like if you want to go for only calcium, you can use calcium FET, you can use sodium FET, you can use magnesium FET. So whatever you want to choose, you can choose such kind of an ion, and then you can go for that reading. So that's about ion sensitive. Then coming to the fifth category called as electrochemical. These are again one of the most important biosensors that are used for diagnostic purposes in the medical field. Okay, so they rely on these three: amperometric, conductometric, potentiometric. So they rely on completely on the conduct, so-called electrical properties. Okay, of the media. So one of the best example is glucose biosensor. So when your blood has a glucose in it, when you want to measure it, nowadays you can see that there are many minute probes coming out. When you insert the probe and then when you put the probe in the so-called reading device, the device will be giving you a value. Okay, how does this device basically work? It's an amperometric device that will be able to measure the current. Okay, so कहाँ से ये current को देख रहा है? Let's see. we have a reaction basically in which your glucose is there in your blood, and your device is going to have a probe. The probe will be having a glucose oxidase enzyme. So this enzyme, when it reacts with the glucose, will get so-called converted. The glucose gets converted to gluconic acid. Okay, and while this gluconic acid is being converted, you are actually going to have two protons and two electrons being liberated outside. So you have oxidation reaction being running, but this particular thing got reduced. Okay, so when this reaction is happening, you have a huge revelation of oxygen, and these oxygen immediately can be recorded. So if you have more levels of oxygen available in the so-called media wherever you are measuring, that says that the glucose content is also higher. Okay, and this can be recorded by its so-called other products like your electrons. So you have an amperometric detection being done by using two different kinds of electrodes. One is platinum electrode and the other one is graphite electrode. So both of them will be able to record this. Okay, or you can go for detection of another byproduct, which is very crucial in regenerating the glucose oxidase from its so-called reduced form to oxidase form. Okay, so this is inversely proportional. The glucose and hydrogen peroxide are inversely proportional. So when you have more glucose, automatically this will be less. When you have less glucose, automatically this will be higher. Okay, so depending upon what you actually want to measure, you can go for oxygen or you can go for hydrogen peroxide. Eventually, both will be giving you the same report. ज़्यादा ऑक्सीजन है, this is directly proportional. कम ऑक्सीजन, कम ग्लूकोज. ज़्यादा ऑक्सीजन, ज़्यादा ग्लूकोज. यहाँ पे इन्वर्सली. ज़्यादा हाइड्रोजन पेरोक्साइड, कम ग्लूकोज. कम हाइड्रोजन पेरोक्साइड, ज़्यादा ग्लूकोज. So depending upon what you want to measure, you can use different types of electrodes, and you can go for this amperometric detection. Then coming to the detection of so-called methods, other applicable methods. So you can use different optical sensors, optical-based systems for evaluating the so-called availability of a foreign DNA particle in a sample. Okay. Example, let's say now we are suffering from COVID. I'll just give you one example so that you can actually understand. Let's say now the entire nation is suffering from COVID. So when we have this COVID, we are going to do the testing. We do the testing by two methods. One is antigen-based method, which we call it as rapid test. And the second one is PCR, real-time PCR, RT-PCR, called as real-time polymerase chain reaction. So polymerase chain reaction क्या होता है? We have a gene of interest which we want to amplify. मतलब हमारे पास उसका जो starting gene का जो starting primer है वो हमारे पास है, enzyme है वो हमारे पास है. हम क्या करेंगे? हम हमारे sample में जो DNA है that we introduce, and we just give all these factors and see if these factors are able to detect that particular gene and amplify it. Okay, so how do we do that? Through a reaction called as polymerase chain reaction. We put it in a machine and this machine will be running up and it will be amplifying. So if the amplification is really happening, we want to detect it in a real time. So what do? We insert a fluorescent dye which actually can bind to the DNA, which is in a double stranded format. So जब आपका gene amplify हो रहा है, automatically it's in double stranded format. So if the value starts appearing as early as third cycle or fifth cycle, then you can say that, oh my God, this fellow has COVID positive. Okay, let's say after 25th cycle also, if nothing is coming out, cyber green का बिल्कुल fluorescent value नहीं आ रहा है, उसका optical detection हो ही नहीं रहा है, fluorescence का. In that case, you see that okay, fine, this fellow is rid of COVID or this fellow is not having any COVID related genes in the sample. So he is clear, or he or she is clear. Okay, so this way the laboratories do this method, and they will be able to give you a report whether it's COVID positive or COVID negative. If you are positive, they will say ki what value actually you got, at what level they got. CT, there is a thing called a cycle of threshold. Okay, so depending upon the CT, you can actually say whether you got COVID or not. Okay, अगर CT 25 के ऊपर है, मतलब it's very less that the person is having COVID infection. If the CT value is below 20, and if it's like near to 10, it's going to be very high. Okay, so the same way you have different other methods also being applied to look at the DNA detection. Like we have FABs, force amplified biological sensors, then we have force differentiation assay, then we have V-direct content. All of them are basically used for the so-called detection of DNA in your eluents. So what are we exactly detecting here? We are using it for detection of any sort of a dangerous thing. like anthrax, botulinum, harmful pathogens. As in case I have observed, I have told you earlier that we are actually looking for a COVID and all. So this way we can go for DNA detection method. Second, we can use it to determine pollutants in nature. Now looking at the non-biotic components, okay, non-biotic, abiotic, okay, pollutants. So there are certain creatures which actually can depend upon the pollutants and survive. What we can do is that we can take them, we can modify them. So how do we modify them? We have a gene that gets activated whenever the pollutant is getting intact. Onto this gene, we add a reporter gene, which we call it as Lux gene. So this Lux gene will also get activated whenever the interaction is happening. So जब भी ये जीन एक्टिवेट होगा तो उसके साथ दूसरा ये जो लक्स जीन है वो भी एक्टिवेट होता है, जिसकी वजह से आपको क्या होता है, you are going to get the behavior related to the pollution happening here. At the same time, you are going to see a glow in the bacteria. The glow is actually coming out because of the reporter. Okay, there is a what do you say, oxidation process happening where the luciferase will be acting on a pigment called luciferin, and during the course of time, uh, this is actually going to give so-called signal in the form of a bioluminescence. Okay, and this luminescence is recorded, and that gives you a value. So when you have more amount of light coming out, it means to say that okay, your sample basically have more amount of pollution. And when you have less light coming out, or if you have no light coming out, then the sample is clear. It has no contaminants in it. Okay. And same way, you can do the colorimetric assays. This is through light. This is through gene modifications. This is through simple immunohistochemistry. So what we can do here is that we can have an antibody of known what do you say, binding efficiency, which binds to the contaminant. When the contaminant comes and binds to the antibody or your so-called non-compound bioelement, this bioelement has a change in the spectrum, and that can be recorded at a specific value, observance value. Okay, or sometimes this binding will give you a color output, which can be detected through colorimeters. Okay, जितना कम कलर होगा उतना कम पोल्यूटेंट्स है, जितना ज्यादा कलर होगा उतना ज्यादा पोल्यूशन है. सेम में यहाँ पे लाइट दिख रहे हैं, हम यहाँ पे कलर दिख रहा है. Okay, so there are different methods. There are different methods for detecting pollutants. So this is like towards looking at the so-called abiotic factors using the biological sensors. Okay, and same way you can also use the biosensors in food. Okay, I'll give you a simple example. Let's say some human being has consumed a good amount of alcohol and he is diving. Okay, let's say that fellow got caught by police, and they have this meter which actually will be giving you a reading of alcohol vapor. So when the person takes the pipe in and then he blows the air outward, that's going to give you a beep. Okay, so how do we actually get the beep? So we have a reference value basically for a regular human being. So regular human being में vapors जो आता है वो vapors में alcohol vapors थोड़ा बहुत होगा, तो उसके थोड़ा दूर तक they keep that as a reference value, and if somebody is drunk a little bit, okay, so the reference value will not be touched. If somebody is drunk too high, then the reference value crosses, and that's where police are worried about. So they just keep you aside and they say that it's not safe to drive. You better stay here and go after home. Okay, and so that way we have different types of devices that actually can look at the so-called contents in the liquid in the food or the beverages. Okay, let's say somebody is coming up with a Maggie and say that मेरे Maggie में 50 ग्राम का प्रोटीन, हर 100 ग्राम में 50 ग्राम का प्रोटीन है. Okay, so people who are bodybuilding and all, they feel that okay, fine, this way I can eat Maggie and this way I can even have the protein content also. So let's say somebody is interested in it, and then let's say somebody is doing that for like 3 months or 4 months, and still his body is not been building up. So if that fellow got pissed off, then what he can do is that he can take this Maggie to the food center, testing center, and in the food testing center, they can go through different parameters testing, and they can give him the nutritional value back. Let's say in the food testing laboratory, the protein content in the Maggie was shown to be as 8 grams. Okay, so this fellow simply he can go take the report, file a case in the consumer forum, and then he can get all the so-called justice done. Okay, so this way many of the companies can be sued. when because most of the companies do play with nutritional component. Okay, वहाँ पे बाहर कुछ और दिया होगा और अंदर कुछ और है. Okay, so this way you can look at the quality of the food, you can look at